In this video, we're going to look at how we use trigonometry to find an unknown angle. We've done lots of things on the unknown sides. But this time, if we have an angle that we want to find. Before we go any further though, we just need to recap on what we mean by inverse operations. You've done this a bit with algebra. What you should know is that if you've got a plus and you need to undo that, then you use the inverse function, which of course is a minus. So a plus and a minus are the inverse of one another and are used to undo each other in algebra. You also know that a times and a divide are the opposite functions. If you have a times and you need to undo it, you use a divide and vice versa. And that's what we mean by inverse operations. We can extend this further into trigonometry, and you need to know that sine with a little -1 is called the inverse of sine. Cos -1 is the inverse of cos, and tan -1 is the inverse of tan. Now what we're going to do is use these to help us undo some trigonometric equations. Now you might have seen these buttons on your calculator. If you have a look at your calculator, above your sine button you've got sine -1. Above your cos you've got cos -1, and above your tan you've got tan -1. Now to use those you have to first of all press this second function here and then pressing your sine. If you have a bit of a go of that now, it'll come up with the sine -1, cos -1 or tan -1. My calculator's not a real one so it won't work, but if I do second and then sine up in here, it will key in sine -1 and open a bracket, and the same for cos and for tan. So let's have a look now and see how that actually helps us in using in undoing our trig equations to find an angle. Here's a question here. Find the value of theta. Now we know that theta is that default name for an angle. So find the value of theta here, correct to the nearest degree. Now we're going to follow these same 6 steps that you've been doing in all of the other trig equations. We're going to label the triangle first in reference to the angle. So here's our angle here. So over there is opposite. This one is adjacent. This one is hypotenuse. Label the triangle. Decide on which trig ratio to use. We have adjacent and we have hypotenuse. Adjacent and hypotenuse is a cos. Adjacent over hypotenuse, and remember you get that from that SOHCAHTOA that you've been using throughout the rest of the chapter. So decide on that, write down the formula we've done. Now substitute the values from your triangle just the same as we've done before. So cos. Now normally we've gone and put an angle in here because we've known the angle, but we don't in this case, so just leave it as theta equals adjacent is 16 over hypotenuse, which is 43. So we've done that. Now solve for the unknown value. The unknown in this case is that theta. That's what we want to find. This is our unknown. This is what we want to get into. So we need to get rid of our cos. To get rid of something in algebra, as we discussed over here, we use the inverse operation. If it was a plus and we needed to get rid of it, we would take it away. If it was a times and we needed to get rid of it, we would divide. We're going to use these inverse operations to help us undo this equation. So to get this theta by itself, we're going to do the inverse of cos, which is cos -1. So theta is the inverse cos of 16 over 43. Now there's a little step we can put in the middle here. I'm just going to move that one down. There's a little step we can put in the middle which might help you a little bit. Oops. Okay, so if I want to get rid of this cos, I do the opposite of cos, which is cos minus 1. So I do cos minus 1 of both sides. Now cos and cos minus 1 are inverse of one another, so they cancel each other out. So I'm just left with theta is cos minus 1 of 16 over 43. What you need to do now is get to your calculator and work this bit out. So on your calculator, you're just going to press, to get this cos minus 1 up here, you need to go second cos. So press the second function and press cos. And then on your display, you'll have cos minus 1 and an open bracket. Now to put the 16 over 43 in, you could use your fraction template here and then put the 16 over 43, but it's just as easy to go 16 divided by 43 and then close your bracket. So 16 divided by 43 and you'd get that. And when you press enter, you should get 68.155. Going back to our list of things to do, solve the unknown value, then it says check your rounding in units. We know we're talking an angle, so our units is degree, but up here in the question it said to round to the nearest degree. So I'm going to say that theta is 68 degrees. 0.155 is only very small, so it rounds it down to 68 degrees. If you haven't managed to press the right buttons on your calculator, pause the video now and try it and just make sure you can get the right answer. I'll do one more example for you. Let's have a look. Find the value of theta in the triangle below. Give your answer to 2 decimal places, and we're going to follow those same steps each time like we've done on the other videos. So here's our angle. Labeling the triangle, I've got opposite and I've got adjacent. Here's hypotenuse over here, but it's blank, so I won't be using that one. I will be using tan. Tan theta is opposite over adjacent, and that's again from SOHCAHTOA. You should have picked up by now that sine and cos both need a hypotenuse. Tan is the only one that doesn't have hypotenuse. So as soon as you see that the hypotenuse is blank, you know you've got to use tan. Next step is to substitute our values. Tan, angle, don't know the angle, leave it as theta, equals opposite 0.56 over adjacent 0.12. I want to get into this tan, so I need to, into the theta, need to get rid of the tan. The opposite of tan is tan minus 1. So I say that theta is the inverse tan of 0.56 over 0.12. On your calculator now, you're going to press second tan, and you'll get that in your display and with an open bracket. Then 0.56 divided by 0.12, or use your fraction template if you want to, but either way you should get 77.91. The question asks us to give our answer to 2 decimal places, and that's exactly what we've done. You'll notice that it was actually 77.905 . 2 decimal places, there's my 2. Because this is a 5, it's going to bump that one up to a 1. So my final answer is 77.91, and we're going to put our degree symbol on there for our units. 77.91 degrees is the final answer. Good luck with that.